Hello everyone, welcome to my YouTube channel, and today we will discuss about the remaining portion of the Maxwell thermodynamic relations. And as I already told that from Maxwell relation two type of question can be asked. The one is that relation between thermodynamic variables like entropy, pressure, temperature and volumes. This part I have already covered in my previous video, and the remaining portion is that they can also ask about the relation between thermodynamic function like enthalpy, Gibbs free energy and internal energy with their thermodynamic variables like entropy, pressure, temperature and volume. For example, this is the one of the example of relation between thermodynamic function and thermodynamic variables. All these type of problems can be asked from can be solved from thermodynamic squares. So before going to problem, you should know about the thermodynamic square. This is the thermodynamic square that I have already drawn here. Suppose we have to find out a thermodynamic relation, Maxwell relation for the thermodynamic variables entropy in term of Maxwell function, means in term of H, G and A and U. We have to find out a relation of entropy with these functions. So let's see how to solve these type of problems. For solving these type of problem, first of all we have to see the diagonally opposite element which is di which is opposite diagonally opposite to that of entropy. Here temperature is the diagonally opposite to the entropy. See, temperature is the diagonally opposite to the entropy, and then we have to see the nearest thermodynamic function. Here Gibbs free energy and this work function is the nearest thermodynamic function. So we have to write the partial derivative of these function with respect to temperature. See, we have to write the partial derivative of Gibbs free energy with respect to temperature. Entropy is equals to, and entropy will be also equal to partial differentiation of A with respect to T. See, now we have to write their constant also. As the Gibbs free energy is lying on this side of the sphere, so here pressure will be the constant, and as here work function, here volume will be the constant. Now we have to mention the sign also, that whether here the plus sign will come or the minus sign will come. So sign will be decided by this temperature. As I already told that if any arrow is coming, then the sign will be taken as negative, and if there is no arrow, then their sign will be taken as positive. Here we can see that arrow is directing towards the temperature, so sign will be taken as negative here also, and here also the arrow is directing towards the temperature, so here also sign will be taken as negative. So this is the relations between the thermodynamic function and the thermodynamic variables, and the things will be more clear when we will solve more problems. Suppose this time we have to find a relation for pressure. This is the pressure. So first of all we have to see the diagonally opposite elements. Here volume is the diagonally opposite element to pressure. So then see the nearest thermodynamic function. Here work function and internal energy is the thermodynamic function which is lying nearest to this volume. Now write the partial differentiation of these work function with respect to volume. See, partial differentiation of A with respect to volume is equals to partial differentiation of u with respect to volume. Now we have to write the constant. So here T is lying on this side, so for work function, so temperature will be the constant, and for internal energy, entropy will be the constant. Now we have to mention the sign, as the arrow is directing towards the volume, so we will take sign as negative in both the cases. Okay, this is then. So in the similar way, you can try for volume and temperature also. Try. Now we can try some question, and this is the question from NET December 2011. Question is, for a system of constant composition, the pressure P is given by, and four different options are given here. So first of all, for solving this type of problem, we have to draw the thermodynamic sphere. See, again and again we are drawing thermodynamic sphere, so it is very important uh, to know about the thermodynamic sphere, and you have to remember all these things. So for solving, we have to find out the value for pressure. We have to solve for pressure. So first of all, we have to draw the we have to see the diagonally opposite element to the pressure. Here it is V, and then we have to see the nearest thermodynamic uh, function. Here is the A and U. So P is equals to, and then we have to write the partial derivative of these function with respect to volume. Curly V is equals to partial differentiation of A by V. So now we have to write the constant. So entropy is on the side of internal energy, so this will be S will be the constant here, and temperature will be the constant in this equation. Now we have to mention the sign. So sign will be negative because there is an arrow directing towards the volume. Negative, negative. So pressure will be either equal to this equation, or pressure will be either equal to this equation. So according to the above question, answer B is the correct option. So this type of problem we have already shown, and the similar type of problem also came in December 2014. The question is, for a process in a closed system, temperature T is equals to. So this is the similar questions, you can do it very easily. For this also, we have to first draw the thermodynamic sphere, write the thermodynamic variables in entropy, pressure, temperature, and volume at the corners, and the thermodynamic function at the side. So we have to draw for, we have to find the temperature T, equation for temperature T. So T is equals to, find the opposite element, and then find the nearest thermodynamic function. So enthalpy and internal energy is the nearest thermodynamic function. So then write the equation with respect to entropy. So curly H by curly S, and here curly U by curly S. Now we have to write their constant. So temperature, pressure is on the side of enthalpy, and volume is for the internal energy, and we have to mention the sign. Now you can see that there is no arrow directing towards the entropy, so the sign will be positive only. So according to this equation, our D is the correct answer. Yeah, another similar question from the GATE 2004. match the following. There are four different options are given here, and we have to match all these with their thermodynamic variables. So this is a very easy question, I think. So try it by yourself, and if you like this video, then please share it. Thanks for watching.